Okay. Well, okay, let's start with a little bit of backstory. I was hired at Tumblr around 3 years ago to build out our entire data center. At that time, we were hosted by SoftLayer in Dallas somewhere, and we had outgrown their solution. We had weird stuff where we ordered servers in different batches. So last year's servers would be in this room in one data center, and our new batches would be in this data center. And there would be latency between the data centers, and sometimes they would do maintenance without letting us know, and our application would crash, and lots of failures. And also, we outgrew their specific servers. We wanted things like PCI flashcards for MySQL databases, and they couldn't offer them. So we decided to build our own data center. Well, not build our data center. We bought some data center space, and we decided to do it ourselves. So at this point, Tumblr was running on 1,000 machines, something like that, but gaining lots and lots of machines every week, at least 20, 30, 40 machines a week. So we were facing an uphill battle, and DevOps or engineering for servers had been like not a priority at all. There was one guy who would jam in some commands sometimes, and some Puppet, so server automation, but organically grown, so it would work, but then it would fail, and then everything would fail. So we decided we needed another plan. So the problem is deploying servers is really repetitive and slow, and you want to automate as much as possible of it, especially when you want to do a large delivery. So we had 1,000 servers. We had a year to migrate to our new data center. We had calculated with that. At that time, with our data center hardware that we bought, we would need around 3,000 servers. And I sure as hell wasn't going to do that by hand. So we started automating things. So the first thing, so the job we don't want is basically unboxing all these fucking things and then getting them actually in production. So we want to make this as easy as possible. So that's what this talk is about, how we got from boxes to actual production. And the way we did it, basically, automation. Lots and lots of automation. I'll go over like our broad view of how we did it. There's individual parts. Most of this stuff is open source, so you can use it. Some of it isn't, but you can easily make it. So some reasons for automation, other than I don't want to do it, is consistency. It's a thing that has bitten me in the ass at LeaseWeb, actually, because some of my servers has been configured with bias settings to performance, and some have been with bias settings set to energy savings. And one server performance is like the database master, and the other one is like the backup. And we fail over to the backup, and suddenly the same workload doesn't work anymore because of my inconsistency. So small things like consistency are like the most important thing when you get to scale. So cost reduction, to give you an idea, we have around 6,000 servers now, and we have 24/7 people at this data center site. And we have 3 people employed that keep all our servers online. So that's the on-site data center people. And at night, it's just one person who's on call, probably at home. So also reliability. We don't want weird issues where one server can't talk to the other one anymore, so that's why we automate. And self-service, we don't want our engineering team to go to the data center team to get some new servers. It should be self-service. So I need a box, you take a box. And it greatly reduced our time to deploy. So automation, you probably have some automation, probably this, automated install of the OS, I don't know, probably, PXE boots, cool. Configuration of the OS, well, we talked about it with Chef is what you're doing. Continue on that. It's good. Use whatever service you want. I don't care, as long as you do it in automated and in controllable and a repeatable fashion. Installing software, well, Chef is handling that for you. Configure software, Chef is handling that to you. Add to DNS, how do you do that?
By hand.
Sorry?
By hand.
By hand?
Yep.
Add to monitoring.
By hand.
Add to trending. So what's the difference between monitoring and trending?
Trending is to see how it evolves and problem that might occur in the future.
So monitoring is just checking if things are online, and trending is indeed graphing and real-time statistics. What is my site doing right now? How many connections, concurrent connections? All the stuff that you read to know right now that indicates if your site is healthy. We have dashboards all over the office saying, okay, we have so many 200s OKs, and then 500s, like something's broken. And then when you see the graph going up 500, something is wrong. Immediately, people start to think like, okay, what happened? So immediate discovery by having trending panels in our office. So that's great for if you want to get incident times lower. Add some screens with some dashboards with trending metrics. Setting firmware, I don't think you do this. Managing firmware, it's a bitch. If you have a...
It's done automatically on my machine, but I had nightmares with firmware.
Yeah, if you have one machine that runs one firmware version and the other one machine that runs another firmware version, your experience can be horrible. You can spend hours and hours debugging why something responds well on one server and not on another server. So having consistent firmware, having that managed is important, especially at scale. Like I said, configuring your BIOS, I don't think you do that. Configuring your rate in an automatic fashion, do you do that?
Yeah,
Almost, all right. Setting up your BMC or IPMI or out-of-band infrastructure so that if you have that? Good. Inventory. Do you know how many servers you have?
Yeah.
Do you know all the details of all the servers? Like how much memory they have, how much disk they have?
Yeah, we got it. It's not available, but we've got it.
Okay. Stress testing. Before you put a new server in production, do you test it? Like stress test it? Manually? We do it in an automated fashion. Network configs. How do you configure, like how do you get your IP addresses? How do you configure your NICs? How do you like do bonding, configure your switches? Manually? Okay. So there's a lot of work here, and there's a lot of things you can learn. So good. So let's start with the simple part. It's inventory. There's a problem with inventory if you don't keep it, if it's not correct, and even worse if you have two systems that have different information in it. So if one system says you have 61 machines and the other one says you're 60 machines, then you're fucked because which one is correct? So what we'll start with is an inventory system. So what we started with a tumbler, and it's going to be our single point of truth. So you can have other systems replicate data, but this is going to be the master. So you can copy it into DNS, but if you change the host name in your inventory, it's going to automatically change in DNS. And it's going to contain some information, so your host name, your hardware information, your networking configs, and IPMI information. And we actually outsourced our inventory app, and it's called Collins. And this thing works. And you can get it for free. And I don't have this thing. And I'm going to show it to you. Basically, Collins is 3 parts. It's a web interface where you can just click for data center engineers to just debug something or find some information. It's a shell, so you can run it in your command line, and it's an API, so you can program against it. For now, I'm gonna probably, I don't know how I'm gonna go on time, but let's just show it. Okay, so this is the search view. Basically, these are all the fields you can look at. Every server has a unique asset tag. So that's our one unique identifier. We don't rely on a asset tag from a supplier to be unique. We just always assign a unique asset. So Dell can give its hardware number, HP can give its hardware number. I don't give a shit. It's Tumblr asset that I'm really worried about. That has to be unique. So what are you interested in? What do you want to see? Basically, I can find all the servers that are not in use. Search. And it will give me a list of all the servers that I can use. For example, oh, this is irritating. For example, let's take this box. This has, it's unallocated. It has been provisioned before, so it still has some old information on there. But it has IPMI information, so go log into the box. That's their root password. Good luck. It's on a VPN, so it doesn't matter. PowerEdge, it's a Dell PowerEdge C6105. It's one of our first machines we bought. It has 2 gigabit NICs. It has 2 processors. It has some memory. It has some 1 disk because it's a web node, so we don't really care. If it fails, we have 1,000 others of them. So there's no redundancy in hard drives here. And it's connected to a PDU and a PDU, and it's actually located located in EWR1, which is our New Jersey data center, in rack C101 is our first rack, and then a U40, so position 40. And I'm gonna, so this is the web interface. I also have an API if I wanna look for new assets for a project, if I wanna scale something. I can just do all the queries that I just did, like the search results. I can query all this stuff via the API, so it's just super easy to program against it. Maybe I'll show it if I have more time at the end. So now we have our single point of truth, but how do we get our data in there? Like, how do we keep consistent track of our data? Well, I did all of this. Oh, well, okay. That was irritating. So how do we get our data in there? So what would be your approach? Like, how did you solve this?
If we're already running Chef, do a post hook in there, get your hardware information from Chef, have Chef be the single source of truth for your inventory system.
All right, not bad. Automation, that's a good. Normally I get the answer is, just import some data from my vendor. Which is basically somebody in India typing in some data. It sucks. So Chef would be a thing, but then you don't know what type of hardware you have until you actually provisioned it. So I solved this problem. Well, we solved it at Tumblr, and then I did it better. The second iteration is always better. The first option we did was make a live CD with CentOS with some bash scripts, and it would run LS hardware to show what CPU, what memory, and PCI cards, and all the stuff that is in there, and it would report that to Collins. But it was a bunch of bash scripts, and every time we made a new hardware class, we would have to rebuild our package, then rebuild our live ISO, and then push out and test that and push that out. It was painful. So instead, I did it with On My Way. It's still a live CD, but it boots, and then you can give it a kernel parameter, and it will git clone a repository, and then go into that repository and run Ansible. If you don't know Ansible, Ansible is like something like Puppet or Chef, but way easier. If you're a system administrator and you know like system commands, you're going to have a hard time figuring out Chef because that's more programming, but you're going to have an amazing time learning Ansible. So I kept it Ansible because I want anybody to be able to intake a server. So your data center personnel that's now intaking hardware can instead start writing Ansible recipes and start implementing all the different hardware classes you have. So the live CD has some utilities, like I said. Ansible runs ls hardware to find out what kind of hardware there is. LLDP, who knows that protocol? Okay. So LLDP is basically your switch being smart, saying, okay, you're connected to this switch and this port. And that way, I don't have to figure that out anymore or manually have that. It has a tool called Break-In. It's our automated stress testing. We'll come back to that. It has IPMI tool to set all the out-of-band IPMI things and some scripts for magic. And it runs Scientific Linux, but you can run it on CentOS or whatever you want. But you just have to build a new live CD. So this is basically an output of LS hardware. It will show you disk 1. It has a disk, and it's from Seagate, and it has a lot of bytes. And basically, that's the report you get for each server. LDP will show you I'm actually connected to the core switch in DFW. I'm connected to port GE003. So now I don't have to trace the cables anymore. It's easy. Here, core switch, port. So the only thing we don't know at this point is our physical location. Where is the server? So we solved that by adding barcodes. There's a barcode on each U position that says just the barcode encoded is U41 or U42, 43, 44. And then there's a barcode on the PDU that says, okay, PDU 1, port 1. And basically, it's just the encoded string, right? And then there's one last part where the server has its ACID tag encoded as a scannable thing. So now, and there's one more where on top of the rack there's an ACID tag that says this is rack C101 or 200. So now we did our automated take-in. We know everything about the server, but not where it is. So our data center technician will come in, scan the top of the rack. Now we know, okay, these are all the servers in rack 101. We'll scan the U position, we'll scan the ACID, we'll scan the PDU port, and we're done. We know where the server is at, what it does, what it can, how it's connected. We have all the information. So a lot of this is just state diagrams. I don't know if you ever did software development, but servers are just in a state and it will transition to another state, and there's things that need to happen before it can transition to another state. So this whole thing is just a state machine. If you want to look into that, figure out states and state machines, but I did my poor man's basically state machine graph. So this is a life cycle of a new server. Basically, we'll buy it, we'll have Dell rack it, and Dell actually ships us the entire rack with all the barcodes and the network connections and the switches, but nothing's configured. So we'll drop in a power supply, we'll drop in a network link, and we power the server on. At this point, it will PXE boot, a network boot, and it will get my On My Way live image, which will start configuring the machine, like setting the BIOS, setting the BMC, configuring the RAID, all the things that you normally do by hand, we've automated. It will then make the intake report, we'll send that to Collins. A data center technician will come in and scan all the things, and the server will go into an unallocated state. At this point, it's ready for consumption. As soon as the data center clears the rack, like, okay, you're ready to rock and roll, you can start provisioning these machines. So where are we with automation? We've installed our OS, we configured OS, installed software, configured software, added to DNS, because we now have our inventory database, which is our single point of truth. I just say, give me all the host names from Collins, and Collins will give me all the servers that I have, and I can just generate all the DNS simple software. Add to monitoring, it's not in there yet. Add to trending, it's not in there. Setting firmware, I did that on my way. Configuring the BIOS, did that with on my way. Setting up the BMC, inventoried. We did no stress testing yet. Ansible can do that, or on my way can do that, but I'll show that in a minute. And we did no network config. So let's go to stress testing. This is break-in. It's a piece of bash scripts that the guys from Advanced Clustering wrote. And it basically does weird things to your machine, like max out the memory as fast as possible, read and write in random bits, write to your disk. So this is a destructive process. It will actually write to disk. So do this before you provision your machine. Don't do this on a live machine, because you will destroy your machine. It will test everything and max out your machine. And we do this for every new rack. So, and we don't do this for 4 hours, we do this for 48 hours. So 48 hours, our machines are maxed out. As soon as one report or multiple at the end of each run, we get a report saying, okay, it failed or it passed. If it failed, a data center technician gets an email and starts looking at the machine. Is the drive dead? Is a memory broken or something like that? This way, we know at least our machines are actually, they arrived correctly there, and this will take out all the easy fails, basically. Your hard drive is shaky when you get delivered, you put it in production, and 2 days later it breaks. This will catch that. So again, we now stress tested. They're still adding to monitoring, adding to trending, and adding to network configuration. So a small overview of our stack, what we're using. We'll PXE boot, that's the network boot. We'll do iPXE, I'll come to that. That's a smarter PXE version. We'll run on my way to get all your asset and your system provision. The information will be stored in Collins. We use an iPXE router, which I'll explain later. We use Kickstart to install our machines. It could be debootstrap if you're using Debian, doesn't make any difference. And then we run Ansible, Puppet, or Chef, whatever you use Chef, fine. And then we have a generator, which actually generates our configurations for us. So let's go to the Collins iPXE router. Basically, this is the part that decides where you want to go. So there's this diagram. Okay, I have this MAC address, and the first question I'm going to ask Collins is this MAC address known? Is this a known server? If Collins says no, I will boot the intake process. If Collins says yes, then I'll ask, oh, do I need to provision this machine? If the answer is yes, then it goes to provisioning. If the answer is no, I'll boot from drive. So how does it do that with iPXE? So iPXE is basically PXE Linux, but on steroids. So you can have it query URL for something. You can have it load over HTTP, FTP, iSCSI, whatever you want. Whereas PXE will only let you download files via TFTP. It is scriptable, so I can extended. I can change the protocol. I can change what I want. It allows for variables, and it's dynamic. And here's an example of how you set up iPXE. Basically, this is your standard DHCP config. It will say, if the user class is iPXE, then actually load some URL that you can configure. Otherwise, just load the iPXE file. So your first user class is probably going to be Dell or HP or whatever, and it's automatically going to load iPXE, and then it gets another DHCP lease, and then it asks, okay, I need this URL, and that URL actually has some information there. So that, oh yeah, and that URL will include the MAC address. So at this point, I have the MAC address of the server, and I can just query URL and include that MAC address, and that way I can actually start scripting and linking things together. So this is our provisioning process. We have two VLANs at Tumblr. One is called provisioning, where you can do maintenance, debugging, intake, all that stuff. And the other one's called production, and that's just production traffic. So if your server is, if you want to go provision a server, the first thing it will do is go into the switch and actually automatically flip the VLAN of the port to provisioning. The server will get a reboot via IPMI. It will start to get a DHCP request. It will PXE boot. It will boot iPXE in after that. Actually, there's some magic things you can do there, but I'll spare you the details. It will start a kickstart or debootstrap, and it will run Puppet on the end. So any questions? Okay, clear workflow. Okay, so now we have provisioned the machine, and this is the life cycle of a machine. Once we have it intaked and provisioned once, you can provision it. It will, on the backside, generate some configs, like your HA proxy or your DNS or your monitoring or your whatever. And once these configs are generated, it will actually move into a production state. It will change your VLAN back to production. And then after you decided, okay, I don't want to use this server anymore, or I want to put it in maintenance mode, or it's broken, you will change the state of the server, and it will update the configuration, take out all of the information, and as soon as all of the configuration is updated and pushed out, you will have an unallocated server again, and somebody else can use it again. So I've talked about generating configurations. I actually made an example. There's a thing called generator, and the GitHub URL's down there. For example, I made a Isinga or Nagios generator, but we use generators for all kinds of things. We use it to generate DNS, HA proxy, Nginx configs, varnish backends, Nagios, and trending. So every part of our configuration management is actually automated and talks to call-ins. So that's where our single point of truth comes in point. If you had multiple systems, this would be a nightmare. But now we only have one system that is always right, and it's going to be easy. Just ask call-ins. So a couple tricks that we learned over the years. Don't just push new configs to production. Actually store them in a Git repository. That's great for auditing. So sometimes what happens is you push a new update to your generator and something wrong happens, and you're like, shit, what happened? And if you just push the configs directly to the server, there's no like stopping it, there's no audit log. So push it into a Git repository and have your chef master or something pull the configs in every minute. Do automated testing of your configs. So HA proxy can run HA proxy -C for configuration testing. Nginx can run Nginx -T for testing. So that's syntax parsing and all that stuff. And only if the test passes, update the new configs. And then push out automated changes with Chef or Puppet, like I said. So now, basically, we have a fully automated system going from systems. Well, all right, Dell unboxes them for us, but to production. So fast, scalable, and no hassle provision. So what happens if a server is broken? It will go from production to maintenance. It will, basically anything can happen. In Collins, you can say, okay, this server needs to go into maintenance, and it has a reason why you put it in maintenance. It could be a broken drive, and depending on what actions you choose, there's actions that come from Collins. So if I say, okay, it's hardware defect, it will send off an email or a ticket into our data center administration team with this drive is broken, the data center, and in the meantime, the generated configs will update, and the server, by the time that our data center engineer comes to it, will be completely out of production. So we removed a hassle of like maintenance from 30 minutes to an hour of an engineer working on a server to get it out of the configuration to 5 minutes, and it's literally the push of a button. So you can decide to have maintenance, swap a drive, swap a motherboard, update RAM, whatever you want to do. As soon as you change anything about the server, you also need to re-intake it again because the hardware profile has changed. And then as soon as you re-intaked, you can start to provision again. So that's sort of the life cycle here.
Yeah, when you do the re-intake, you get the MAC address from the MAC address still the same, so it detects that it has been added to Collins before.
Sure, if it's set to maintenance mode and the MAC address is known, you can re-intake. If you change the motherboard, the MAC address is different, I don't know this MAC address, automatically goes to intake. Lessons learned, modularity is very important. Don't build a live CD that you have to change every time you make a typo. It takes a very long time to build a live image. So modularity there. And all the different systems are modular. So we have Collins in the center and then all these systems around it, like the generator or stuff like that. And another thing, if you order 3,000 machines at a time, then you're going to be guaranteed that some things are broken. I can tell you lots of funny stories of how our data center migration almost failed, but it didn't. It actually went in 6 hours downtime and perfectly fine. So use bash syntax. That's actually for the old Invisible Touch. Use Ansible. It's awesome. Don't use bash. Well, if you want to use bash, fine. And 4 hours of burn-in time of a new data center is not good enough. Any questions? This is my name. This is the slide that I have to put in from Tumblr. Sorry.